Give another 1 minute, for your friends. Okay, students. Okay, let's restart. Okay, so we done everything ready for gravity. Okay, gravitational field we done, force per unit mass, field point, the electric field strength near the Earth. We done with the reason one we done is the gravitational potential. Okay, so let's recap first what we learned. The entire for one round. Okay, so I have to do this because better understanding. Okay, so what is the first thing you learn about gravity? Newton's law of gravitation. Okay, first of all, can you hear me? Yes.
Yes, yes.
You can see the whiteboard, Can,
Yes.
Can, okay. So what is the first equation you learn? The Newton's law of gravitation said what? The force between two masses are the product of the masses inversely proportional to the square of the distance. Unit is Newton, and it's a vector quantity. Okay, vector. Next, what do you learn? Gravitational field strength is, what is gravitational field strength defined as? Force per unit mass. So GMM over R squared divided by the test mass, GM over R squared. Unit is what? Newton per kg. Also vector. Okay. Which last time we learned G as 9.81 is actually this quantity, but now it varies. Third, you learn about what? After gravity, you learn about orbital speed. Okay, orbital speed. How do you get orbital speed? Fc equals to Fg. Fc is mr. Fc is what? Mr omega squared equals to gmm over r squared. Then in halfway, the omega we substitute 2 pi over t squared. Then it's gmm over r squared. Then end up getting t squared equals to 4 pi squared gm r cubed. This is the third equation. Then after that, you learn about, this is not orbital speed. This is your period formula. So how do you get the orbital speed? The fourth one, orbital speed. The orbital speed you get again Fc equals to Fg, but Fc is what? Mv squared over r. Fg is gmm r squared. So end up the orbital speed root of gm over r of the equation. These are the 4 equations you got. So it's getting messy. Okay, so you use here. Okay, then the fifth one, get potential energy. Okay, gravitational potential energy, U. So what's the formula? Negative gmm over r. Something new you learn. 6, you learn gravitational potential. Okay, gravitational potential. What is the negative gm over r? This unit is joule per kg. It's a scalar quantity. A scalar. This unit is joule, also scalar, scalar quantity. Then after that, 7, you learn what speed? Escape speed. What is escape speed? Escape from the Earth's surface. So what equals to what? You get escape speed? Anyone? Kinetic energy is equals to the potential energy So end up giving you a escape speed formula. What is the escape speed formula you got? Root of 2 gm over r. Yes. So these are the entire thing you learn for gravity. Okay. This is what you learn in under gravitation. Okay. We have all the formulas up to 7. The problem of these formulas is all the formulas contains gm. Remember, all got contains gm. Okay, that's the problem. Okay. Another one thing important, the gm, right? The gm. Sometimes the mass of the planet not provided. Remember, the gm can be replaced with gr squared. G is the gravitational field strength on the surface, normally 9.81, and the r we put capital R, r squared. R is the radius of the Earth. Okay. Okay, if they give the radius of the Earth, they give the gravity at the surface, the gm can be replaced with gr squared. Remember, okay. So don't check some question. Mass of the planet required, but mass of the planet not required. Mass of the planet not given, but they give the gravity and the radius of the Earth. So you can substitute gm with gr squared. A very common what do you call substitution. Okay. Okay. So now let's see, move on. We do questions now. We done that. Okay, we done everything. Okay, so now we're going to implement that formulas. So we done everything. So here in these notes, we can do the questions in between here and there, given gap, easy questions. Straight go to the last part. Okay. So this is your, you can give a try, and there is answers at the back for you to understand. You go through this. Okay, the one we're going to do today is before this work example here. Yeah, this one. The day we did 1 and 2. Okay. Today, let's we try together. 3, 4, 5. These 3. Okay. So first, let's we look at 3. Use what the entire thing you learned today. Okay. How do you go about number 3? You tell me what equation to be used, what need to be done. Okay. So, sorry, these are the equations. You can take a snap. Maybe take a camera, you can snap it. So 1, 2, 3, 3, this is the third equation. This is the fourth equation. This is the fifth equation. Okay. I want me to tell what formula do you going to use? 3, this is 3, sorry. This 3, this 4, this 5, 6, 7. 7 equations. Remember the 7 equations. 7. Which equation you use? Okay. You take a snapshot first. Okay, you already take one. So you go back to the question. Okay, let's go back to the question. Okay. Number 3. 3 minutes for you. Take a piece of paper. Get the answer. You should get the answer inside the bracket. Try to figure out. Maybe I write the equation here easier. So F equals to GMM over R squared. This one. G equals to GM over R squared. Second one. T squared equals to 4 pi squared gm r cube. That one. Orbital speed root of gm over r. And potential negative gmm over r. Gravitational potential negative gm over r. Fourth one, fifth one, sixth one, 7 escape speed root of 2 gm over r. Gm can be replaced with gr squared. 7. Okay. Sorry, let me put it aside. Okay, actually you can find these notes, this document in your times. Okay, you can access it. You should not rely. You no need to rely on it from my side. Okay, for the third one. So what formula do you use to calculate the answer? What the question was? Number 3. From the Earth, yeah. Which equation we used?
The E equals to negative G M over R.
So the fifth one, the fifth one to be used.
You.
So the question asking what? From Earth surface, which is R, what is the what is work done? Earth, calculate the least kinetic energy which must be given. What is the kinetic energy must be given for the object to move from the surface to another point where the total distance from the center is found to be R0. How much kinetic energy is required? Okay. So how do you calculate with this? The kinetic energy required should be equivalent to work done. The change in potential energy. And the change in potential energy. This is one point. So change in potential energy is what? The change lah, the change. So of course we supposed to write like this lah. This is here. Changes in EK plus changes in U must be 0. Okay. Changes in EK plus changes in U must be 0. The change in kinetic energy must be change in potential energy. So changes in kinetic energy is what? The final minus kinetic energy initial should be plus final minus initial potential energy should be 0. Okay. You are looking for which kinetic energy? You are looking for initial kinetic energy. Final kinetic energy how much? Become 0. 0 minus initial kinetic energy plus final potential energy is what? Negative mm over r or r naught. Final potential energy is the final potential energy here, right? So gmm over r naught minus initial potential energy at the surface is what? Another minus gmm over r. Okay. is equals to 0. So to get answer, so EK required is this minus this plus this becomes, so final become what? GMM over R naught plus goes there, minus, right? Plus minus GMM over R. GMM over R. That's a mistake. Minus plus goes there, this become plus. Final potential, oh sorry, this is the final. Final potential minus the initial potential. Yeah, correct. So this should be the answer. Okay. What's the marks scheme given? Sorry. So 1.33 times 8 point. So how to get 1.33? They give 1.33. Negative GMM over R. What do you get? Final minus initial. Oh yeah, correct. This is still negative, right? Negative VK, Negative VK. So if this become positive means I made a mistake. Another step, another one step, Another one step, I go here. I do here, another one step. The negative and go to the other side. So EK required is how much? Will be GMM over R minus GMM over R naught. Yeah, okay. So what is the EK required? GMM over R. Can you substitute the values? And this is R naught, yeah, R naught, capital R naught. So what do you get? Okay, so GMM over R, how much you get? Negative GMM over R naught. Let me go back to the question for me to view. So how do you get 1.3 times 10 to the power of 11? That should be your GMM over R. G given, M mass of the planet given, small mass given. Yeah, 2000 kilogram is the small mass. Over R, 6.4 times 10 to the power 6. You should get 1.3 times 10 to the power of 11. Okay. This 8 times 10 to the power of 11 is actually what? GMM. GMM. So, from this working, this you should get how much? 1.3. You get 1.3 times 10 to the power of 11. So here you should get 1.3 times 10 to the power of 11 minus the GMM alone. Multiply, you should get 8 times 10 to the power of 11. 70. Okay, we get 8 times 10 to the power of 70 over R. So this is what you should get. This is how the flow. So this is the working for number 3. Okay, we start with what? From here. Okay, changes in kinetic energy plus changes in potential energy is equals to 0. I think we better write like this because to avoid any proper mechanism handling with the negative values. The changes in EK always write final minus initial. Changes in potential also final minus initial. Then the sign will be properly handled. The final kinetic energy 0, initial is negative, and so you can arrange to get the kinetic energy required because the kinetic energy requires the initial kinetic energy. Okay, so this is the working for number what? Number 3. Any part you don't understand?
Does that mean because from what I did it, I only use R, not capital R?
You only use R, small r. Okay, yeah. So the radius of the Earth should be capital R, yeah. radius of the Earth. But you need to use R and R naught, right? R naught is from the center to the point. Right? That's your R naught, right?
Yeah, but at the question it says that R is from the center of the earth, right?
R, oh yeah, capital R is what? R is the radius of the Earth, right? It's capital R,
Oh, oh, I see.
capital R, radius of the Earth.
Oh,
Okay, radius of the Earth. R naught is from the center to the point where you want to stop.
oh,
That's your
which
R naught.
is R not?
R naught is from the center of the Earth to the point where you want to reach. That's your R naught. R is the capital R is the radius of the Earth.
Can I see the question again?
The least kinetic energy which must be given to the mass of 2000 kg at the Earth's surface, for the mass to reach a point of distance of R naught from the center of the Earth. So R naught from the center of the Earth to the point where you need to reach. That's your R
Oh,
naught.
I see. But where is the value?
R naught value not given, but the final answer they want in terms of R naught.
Oh, in terms of R not, okay.
Answer given is in terms of R naught. Okay, so number three, So number three is something to do with kinetic energy, potential energy. Then the formula must come to your mind. Of course, the potential energy and the gravitational potential sometimes. These are the two things you have to use. Don't forget the negative for gravitational potential energy. Oh, I missed out another one formula important. What is another one formula I missed out? Is these two relation. The potential energy is equals to gravitational potential multiplied by the mass. It's another one formula. Can say number what? Number 8. Okay, so I go back. You can take down the picture if you want. This is the working expected. And number 3, those who don't understand, go through, take a picture, you do the working later. Okay, any part you don't understand, anyone? Changes in EK plus changes in U equals to 0. So the formula is negative GMMR. Okay, any questions? Okay, no questions. We go to the next one. Look at the question, check which equation to be used, try to work out. I give you 3 minutes again. Then we do together. But I want you to try first. Okay. Okay, go down. Good. Yes, next one. Number 4. For part A and B, you can use radius of the Earth as 6,370 kilometer given there. Try to get the answer in the bracket. Okay. Check which formula to be used. Okay, I minimize it so that it can expose to the formula. Give you 3 minutes. Get some working. 3 to 4 minutes. Come on. Try to get some idea before we do together. Try to figure out which formula you think suitable and how do you go about. You just do the working. If you get the figure at the bracket, that means you are correct. All the formulas written at the side. Okay, class. So maybe you have some idea. Okay, tell me which equation to be used. There are actually one equation, but later you need to do some sort of substitution. Which equation to be used for the part A? Anyone? Give a try. Wrong, never mind. Just give a try. Okay. A preliminary stage of spacecraft Apollo journey to the moon was placed in a Earth parking orbit. This orbit was circular, maintaining the almost a constant distance from 189 kilometers from the Earth's surface. Assuming the gravitational field strength in this orbit is 9.4, calculate the speed of the spacecraft in the orbit. Okay, so anyone got an answer? Which for equation to be used? Come on, it's helpful for your other friends too. 1 to 7, there are 8 equations listed at the side here. Which equation?
Square root of gm over r.
Very good. So equation 4, right? Orbital speed to be used. Orbital speed. Is it all the information given to you?
No.
No. What is not given?
Small
Mass,
r.
small
Or mass.
r. Mass of the planet not given. Okay. So how do you substitute the if mass not given? Which formula to be used? The GM we substitute with
gl squared.
GR squared. This G is the gravity at that radius. Normally the G 9.81 and the radius is going to be radius of the Earth. But here they give gravity of which point? Gravity of that orbital radius. So the small g you take it as 9.4. The R you take which R? The radius of the orbit. Where's your radius of the orbit? 189 kilometer plus the radius of the Earth. That's your capital R. Okay.
Oh,
Then if
radius of Earth is given.
the here they make you tricky. They give the what? They give the altitude 189 kilometer. But all the formula, the R used is from the center to the point. So how do you work out? Let me. So hope if you get. Oh, sorry. Get this first.
Yeah, so the formula, the unit for R is meters or kilometers.
Always have to be SI meter.
Okay.
Okay, so sorry. Let me some. So what they said, this is the Earth. The spaceship is going around. Let's say I put like a satellite. So it's going around the Earth, the planet. They said the altitude is found to be how much? It's 189 kilometer, and the radius of the Earth is given, are given. Okay, asking what speed is moving. What is the orbital speed? What is the orbital speed? So orbital speed is root of gm over r. Okay, but gm not given. So we know gm can be replaced with gr squared over r. But in this case, the capital R and small r, is it same for this case? The small r is from the center to there. The capital R also from the center to there. It's actually same. So we put it as r squared on top, like small r squared. So end up getting what? End up getting root of gr only. This is the orbital speed. So you should get root of g how much? G is how much? G is 9.4. Okay. Multiply by the R, the orbital radius, which is orbital radius, a little tedious to do. The radius of the Earth, 6370 times 10 to the power of 3 plus with the 189 kilometer. The 189. Okay, let me expand this for a while. Okay, so I do here, root of 9.4 times what? 6370 times 10 to the power of 3 plus 189 times 10 to the power of 3. Yep, this should be your orbital speed. So the idea is drawing the diagram, try to understand, you need to use the orbital speed. Gm, mass of the planet not given, gr squared. The r and r here is the same. In this case is the same, not always same, Sometimes they give gravity 9.81 and the r should be the radius of the earth. So top will be r, capital R. So they won't be same. Small r at the bottom is the orbital radius. The top can be the radius of the earth sometimes. In this case, they are happen to be the same. So cancel the gr, square root of gr. So you substitute the g and this. And the r is from the center to the point. They give altitude, another trap. We must plus the radius of the earth to get the total r. Get the radius.
So why is capital R changed to R? Because negligible.
In this case, the same one. Because
Same.
this r is the orbital radius. The gm, the gr squared, the gravity they give the gravity of the at this orbit one. Gravity at this orbit is 9.4. So the r used for that gravity is also that same orbital r1. So the gm can change to gr squared. Okay. Sometimes they give the g of the surface, g at the surface. G at the surface, they'll tell you 9.81, 9.81. Then the r you must use is the radius of the earth. You must use the radius of the earth.
Oh.
So in that case, in this case, it's root of g r squared over r. This r, the capital R is the radius of the earth. Radius of the earth. This small r is the orbital radius. In
Also
this
that
case, they are not same. You cannot cancel.
so that means that since G is already given that G is that altitude, that means that it's technically already has been changed
Yeah, correct.
due
Yeah,
to being relative to that position.
yeah, correct. So they could already give that for that r. They already give this the gravity. So you have to use this orbital r.
But if they don't give G that altitude, that means we must use R capital.
But if they say, yeah, they have to tell you that the surface is 9.81. They will tell you the g
Also,
at the surface is
if
9.81.
if they say G is 9.81 and also surface, that means I need to use capital R for
Yeah,
the one that is in that altitude.
yeah, correct.
Okay.
So do you get this answer?
Yes.
Okay, so you should get how much? 7852. Eh? So get 7852 meter per second. Okay. Okay, so this is the working for the question for part A. Okay, so let's we move on to part B. Guys, come on, give a try. Try to figure out which formula. How do you go about? Okay, I scroll down again. Okay, part B. 3 minutes for you. Get the 5250 second. Which formula do you think is suitable? Okay, students, come on. The others, I want you to try. Tell me which equation. Which
T,
equation do you? Yeah.
T squared equals to 4 pi squared divided by gm that times cube.
Okay, very good. So equation 3 to be used to find the period. So time to complete one orbit. So you have to use the third equation. This is looks little straightforward. So you're looking for period. 4 pi squared. Okay. G mass. Okay. Again, gm. Gm you have to replace with gr squared. 9.4 times the orbital radius from the center to the point. Then this r is again can cancel. R can cancel, right? Check. Do you get 5250? Okay. So let me clear this. So they want the period. So t squared equals to 4 pi squared gm r cube. But in this case, t squared 4 pi squared. The gm is actually g r squared r cube. In this case, the r is the same. So we can cancel. The formula turned to become t squared equals to 4 pi squared r over g. So we can find the period. Period is root of 4 pi squared r over g. So your r is how much? Your r should be from the planet center to the point there. So radius plus the 189 kilometer again. The radius also you add. Then g of course is how much? 9.4. You square root it. You should get 5250 seconds. Okay, you should get 5250 seconds. Make sure all SI unit. The R, the kilometer, make sure you change to meter. Okay. The R is not 189 kilometer change to meter plus with the radius of the earth. The radius of the earth, you need to add with what? 6370 times 10 power 3 also. Both add up, become the R. Okay. Any questions? Okay. So I hope everyone get the answer. Okay. Let's go to the last question. Okay, the last one. Three minutes for you. Come on, those who haven't tried, come on, give a try. Try to get the answer working. The last question. Figure out which equation to be used. How do you go about? Okay, class. So get some idea. Calculate the centripetal force acting on the satellite. It's found to be 14.4. How they got it? It's a very small satellite, 66 kilogram. I think it's like the I think the first flight, the Sputnik by the Russia is around that kilogram, around 70 kilogram, if I'm not mistaken. It's launched. It's a very low centripetal force. So how do you do this? Which formula to be used? Which formula? Come on. 1 to 8. So try to understand the question. The Earth okay, the Earth is R. The Earth is R. Remember, from the surface of the Earth to point where the satellite is launched is 5.7 R. 5.7 R is from the surface to the point where it's rotating. So from the center to that point of rotating is actually 6.7 R. That's the traveler. So they say gravity at the surface is 9.8, where the radius is R. This is useful. We can replace the GM later in terms of GR squared. Okay, this must be in your mind. Okay, now calculate the centripetal force acting on the satellite. So at this point, what is the centripetal force? How do you get centripetal force? Centripetal force is same as the gravitational force. So what is the gravitational force formula? G M M over R squared. This formula must come to your mind. So let me expand this, no space. Okay, let me do here. So what happened? So FC is actually FC is FG. So GM be replaced with GR squared M over this R is this R at the bottom is how many R? The R at the bottom. How many R? From the center to the point. How many R? Should be 6.7 R squared. Okay. So finally, what happened? This is GR squared M over 6.7 squared R squared. So this should be your centripetal force. So if I do here, okay, sorry, space. So the FC is equals to GR squared M over what? 6.7, sorry, R squared cancel. That's it, 6.7 squared. So G is how much? 9.8. M, mass of the planet given, sorry. This mass of the satellite. Mass of the satellite is how much? Mass of the satellite given is 66 kilogram. This will be 66 kilogram over 6.7 squared. This should be your answer. You have 14.4. Please try, give a try. So all of you got 14.4. Okay, so this is the flow. FC is equals to FG. FG, GMM over R squared. Mass of the planet are given, GM throw out, put GR squared. The gravity at the radius of the Earth, so we put G capital R squared. M over, in this case, bottom R is the orbital radius, which is 6.7 R squared. In this case, the R on top and bottom is not the same. So you cancel. So you get this. Do you get 14.4? 9.8 times 66 divided by 6.7 squared. Do you got 14.4? .8 times 66 divided by 0.7. You get that answer? Yes, 14.4.
Yes.
Okay, so this is the working for the centripetal force. You know, calculate the period of the satellite in orbit in hours. Okay, how do you find the period? Which formula to use? Of course, number 3. Use this formula. T squared equals to 4 pi squared GM. Again, GM replaced with GR squared and R cube. The R at the bottom and the R on top is not same again. R at the bottom is the radius of the Earth. R on the top is the orbital distance, orbital distance. So they are not the same. You substitute, you should get 24 point. You should get in seconds, then change to hour. Divide by 3,600, you should get 24.5. Okay. So this is the one example. Okay. One example for you for the assignment, for the gravitation. So I believe you can find the period. Just use the third formula. So class, so we did together the entire questions here from the beginning to the end. Okay. Now today I want you to go through, maybe tomorrow you go through these questions, okay, and look at the working. Try to strengthen your idea. Okay, try to strengthen the idea. So tomorrow we'll be discussing questions. I give you questions you have to do, and you need to submit to me tomorrow. Gravitation and circular motion together. Okay, I will submit the question tomorrow morning. I'll show you. Okay, any questions, guys?
No.
No questions. Okay, so I see you tomorrow 8 o'clock with more assignment questions for us to discuss. Okay, so I stop here. Okay, see you guys. Bye. All of you, yeah. Guys, by the way, I already post all the gravitational videos in the Moodle. You can go and check under here. Okay, you can check under your A2 on AS. You go to under A2 online classes. A2 online classes at the bottom. I already put the gravitation, the first 3 parts. These 2 parts I'll upload later. Okay, you can view the videos, you can check the notes, and get ready for tomorrow. Okay.